go with this.
No, absolutely not.
Frederick Griffith here with my assistant / rat handler. I'm going to talk today about how I initially began starting an experiment where I was studying how pneumonia was affecting mammals and how I found out that outside DNA can affect your genotypes and your phenotypes. And Fallon here is going to start us off and tell us, how we started this experiment out.
Well, in here we have some living non-pathogenic strands of our bacteria, also known as the R strand. And as you can see, this rat did not die because it's non-pathogenic, which means it's harmless.
Yes. But we are then going to put pathogenic bacteria into this vial and then inject it into the S strand, also known as smooth, and inject it into this mouse. Dead. Completely dead. So what next, Fallon?
Well, now we're going to use this pathogenic bacteria, but it's been killed by heat.
Yes.
And injected into this other mouse. This other different mouse. But as you can see, he's okay.
Yay! Alrighty, so next we are going to show how we are going to combine the dead non-pathogenic bacteria with the living pathogenic bacteria into this vial and inject it into the mouse, and we want to see what happens. Oh my gosh, he died. How did that even happen? I don't understand. Fallon, what do you think?
Well, the dead pathogenic bacteria's DNA ended up affecting the phenotype and the genotype of the living non-pathogenic bacteria, which transformed it into a pathogenic bacteria, thus killing our mouse.
You're a genius, Fallon. Jeez, that's crazy. That means the outside DNA can affect your phenotype and your genotype?
Exactly.
Oh my gosh. This is like a scientific discovery.
Okay, so in review, the experiment was conducted in 1928 by Frederick Griffith.
And bacteria Staphylococcus pneumonia, there was 2 strands. It was the rough strain, which was non-pathogenic, and there was the smooth strain, which was pathogenic.
There were 4 different things that were done, and number 1 was that the harmless strain was injected into a rat, which resulted in it living, and then the second one was the dangerous strain, which was pathogenic, which killed the rat. Then the pathogenic bacteria was killed using heat and injected into a rat, which resulted in it still living, and then they were mixed, the dead pathogenic bacteria and the living non-pathogenic bacteria, which ended up killing the rat as well.
Right, yeah, and the bacteria that was used in this one, the pathogenic one, was the one that was killed by heat. And so this is called transformation, and so that's what he called it, and it means that DNA from outside can affect the genotypes and the phenotypes of new organisms.
Yep. Hope that helps. I think the glasses are gonna have to be cut.
Wait, why do you say that?
Because we're inside and it's dim.
Hello, fellow scientists. This is Frederick Griffith here.
You know what year your experiment was in?
What? Hello, fellow scientists. Here is me. Start over. Hello, fellow scientists. This here. Start over. Hello, fellow scientists. Frederick Griffith here.
Oh look, he's okay, because non-pathogenic means harmless. We can't get the rat.
Alright, so
Also,
we're gonna start it off.
Also,
What?
we are reenacting it, not explaining it.
Yeah, I know, so we need mouse.
Yeah.
So the first thing that I did was I took the pathogenic bacteria and killed it. But not with the knife. I killed it with heat. Is that what I said? I was going to say that. We are going to show you how we are going to kill this rat. And how killing the rat has helped us discover the role of DNA in genetics.